Very good morning, student. Today, let me start the physics class, 10th lesson. The topic name is diode. Topic name is diodes. N Junction formation. What is meant by P-type semiconductor? What is meant by N-type semiconductor? Already we have learned in the previous video. P-type semiconductor means the doping process, that means impurity added with the semiconductor, the silicon semiconductor. The holes are generated here. Trivalent impurities added with the semiconductor. Holes are generated means is called P-type semiconductor. When the pentavalent impurities added with the semiconductor, it will produce the electrons. So that is why it is called N-type semiconductor. Here P-type and N-type join together form a junction. It is called P-N junction formation. The first important point from the P-N junction formation is formation of depletion layer. This is the depletion layer here. This is the depletion layer. How the depletion layer formed? A single piece of semiconductor crystal is suitable, doped such that its one side is P-type semiconductor and the other side is N-type semiconductor. The contact surface between the two sides is called the P-N junction. So P-N junction means P-type of semiconductor and N-type of semiconductor close together, fixed close together. So this formation of the two different kinds of semiconductor, it will produce the junction. It is called P-N junction. So this is the definition of P-N junction. Contact surface between the two sides is called P-N junction. Which sides? P-type and N-type semiconductor side. The next definition is diffusion current. What is meant by diffusion current? Diffusion of the majority charge carrier across the junctions gives rise to an electric current called diffusion current. Majority charge carrier. Here, majority charge carrier is volts. This direction is diffusion current. Here, in this direction, left hand side direction, right to left direction, this current is called as the drift current. So, the majority charge carrier fixed the direction of flow of current is nothing but diffusion current. That means diffusion of the majority charge carrier across the junction gives rise to an electric current called diffusion current. The next, depletion region. What is meant by depletion region? The thin region near the junction which is free from the charge carrier, that means free electrons and holes, is called the depletion region. This is the depletion region. Here in this region, the electrons and holes are placed in this thin layer. That is why it is called depletion region. The thin region near the junction which is free from the charge carrier, that means free electrons and holes, is called depletion region. The next definition is, what is meant by drift current? So this is the next definition. Drift current. Drift current means the current, electric current produced due to the motion of minority charge carriers by the electric field is known as drift current. Here minority charge carrier is nothing but this is the minority charge carrier, N-type side. So the motion of the minority charge carrier by the electric field is known as drift current. Motion by the minority charge carrier by the electric field. Motion of the minority charge carriers by the electric field is known as drift current. The next concept is junction potential or barrier potential. What is meant by barrier or junction potential? Here this is the definition. This difference is potential across the depletion layer is called the barrier potential. Barrier potential VB. So in this 25 degrees Celsius, this barrier potential is approximately 0.7 volt from the silicon and 0.3 volt for germanium. 0.7 volt for silicon and 0.3 volt for germanium. This is the barrier potential. Here, this is the barrier potential. Potential difference across the depletion layer. Here, this is the potential. Here, positive potential and here, negative potential. So, potential across the depletion layer. This is the depletion layer. Potential across the depletion layer is called barrier potential. The next, what is meant by PN junction diode? A PN junction diode is formed when a P-type semiconductor is fused with an N-type semiconductor. Please note it down, children. PN junction diode means a PN junction diode is formed when a P-type semiconductor is fused with an N-type semiconductor. It is a device with single PN junction as shown in this figure. This is the figure of PN junction diode. The next definition, two more definition is biasing a diodes. Biasing a diode means providing external energy to charge carriers to overcome the barrier potential and make them move in the particular direction. Here, when we connected the external energy, this is the external energy. This external energy to charge carrier, providing the external energy to charge carrier to overcome this potential barrier potential and make them move in the particular direction. So, external கொடுக்கிற எனர்ஜி தான் இந்த சார்ஜ் பார்ட்டிகல் எந்த டைரக்ஷன்ல மூவ் பண்ணணும்ன்ற டைரக்ஷனை ஃபிக்ஸ் பண்ணிட்டு அப்போ பொட்டன்ஷியல் பேரியர் என்றது தட் இஸ் a barrier potential என்ன ஆயிருது ஓவர்கம் பண்ணிதான் இந்த டைரக்ஷனை ஃபிக்ஸ் பண்ணுது. இட் இஸ் கால்டு பயாசிங் டயோட். அதுக்கு தான் பயாசிங் டயோட். The external voltage applied to the PN junction is called biasing voltage. இந்த voltage external energy கொடுக்கிறதுக்காக யூஸ் பண்ற voltage தான் நான் சொல்றோம் biasing voltage. There are two types of biasing. One is the forward bias, another one is the reversed bias. What is meant by forward bias? When the P type of the semiconductor connected to the positive terminal and the N type of the semiconductor connected to the negative terminal, what happened? Positive P type already it has positive holes, then N type it has already negative electrons, that is this negative terminal connected to the negative type of electrons, that means N type semiconductor. This plus, that means positive potential connected to the holes of the P type semiconductor, means positive repel to each other, negative repel to each other. Then the depletion layer with this narrow, இது என்ன ஆயிடும் ரெடியூஸ் ஆகும். பிகாஸ் இந்த பாசிட்டிவ் ஹோல்ஸும் ரிப்பல் ஆகும். இயர் நெகட்டிவ் ரிப்பல் ஆகும்போது ரிப்பல்ஷன் ப்ராசஸ்னால டிப்ளீஷன் லேயர் வித் டிக்ரீசஸ். டிப்ளீஷன் லேயர் வித் டிக்ரீஸ் ஆகுதுன்னா அங்க கரண்ட் ஃப்ளோ ஃப்ரம் ஹோல்ஸ் டு எலக்ட்ரான்ஸ், தென் எலக்ட்ரான்ஸ் டு ஹோல்ஸ், ரீகாம்பினேஷன் டேக்ஸ் பிளேஸ். இது என்ன சொல்றோம்? ரீகாம்பினேஷன் take place in the depletion region. This direction of current flows biasing is called forward biasing. Then reverse bias. Reverse bias means when the P-type semiconductor is connected to the negative terminal of the battery, then N-type semiconductor connected to the positive. So minus connected to the plus holes P-type semiconductor connected to the negative terminal, then negative electrons connected to the positive terminal. What happens? Depletion layer with this increases. The attractional force acting two sides of the semiconductor. P-type la irukka holes enna pannum? Negative terminal attract pannum. Then N-type la irukka electrons positive terminal attract பண்ணும்போது depletion layer with increase ஆகும். Depletion region automatically increases attracted due to the attractive force. இங்க இருக்கிற attractional forceனால. So இந்த directionல போற current தான் is called reversed current. Reversed biasing. இந்த process என்ன சொல்றோம்? Reversed biasing. So here majority carrier, minority carrier நம்ம already சொன்னோம். Majority carrier holes and minority carrier electrons. இந்த இடத்துல repulsion forceனால depletion layer with decrease ஆகுது, that is a forward bias. Here attractional force acting between the acting on the two sides of the semiconductor. So அங்க என்ன ஆகுதுன்னா நம்மளுக்கு மெஜாரிட்டி மைனாரிட்டி சார்ஜ் கேரியர் அட்ராக்ஷன் ஃபோர்ஸ்னால மூவ் பண்ணும்போது depletion region is increases. This mode of process is called reversed biasing process. The next topic is characteristics of a junction diode. Characteristics of junction diode. Next video let me discuss about this question. This is a very important 5 mark question as well as the practical topic also. Thank you very much, children.